Good morning, class. Here's the final exam review covering modules 1 to 4, trigonometric functions, identities, equations, applications, periodic functions, all of the above, and we are going to continue with the rest of the final exam review. So what did we do? First, we looked at the basics as far as the concept of quadrants, unit circles, relationship between degrees and radians. We looked at arc length, S equals r theta, area of a sector, area is 1/2 r squared theta, applications of that. Using identities such as Pythagorean identities, the fact that sinusoidal functions are all periodic functions, we simplified trigonometric expressions, graphing sinusoidal functions, trigonometric functions such as sine functions and cosine functions, and others. We looked at inverse trigonometric functions and the fact that they have to be limited in their domain, the restriction on their domain to make them a one-to-one function, otherwise they are not, because they are all periodic functions. We looked at more inverse functions. We added trigonometric identities, such as sum, difference, half angle, double angle, and so on. We used them to come up with the exact value of certain functions. We looked at proof of some identities. We could find exact values of expressions without a calculator. Again, using identities. We established identities. We looked at proof in essence as we go from one side to the other, from the left-hand side or the right-hand side. Normally, we would start with the more complicated side, and we looked at solving equations. In this case, we had to use an identity to get there. So we noticed we have cosine squared, sine squared, and since this was sine, we decided, since this is sine, we decided to change this one. And we went through the process. We solved this equation. This was the last one. We're going to continue looking at more equations. Two cosine squared minus cosine theta minus 1 equals 0, and we are interested in finding the angle between 0 and 2 pi. Since everything involves cosine squared, simply cosine and cosine squared, simply we factor. This is a number 2 is a prime number, so you need 2 cosine theta and cosine theta. This is -1, just 1 and -1. Put them in a proper order such that the middle term minus cosine theta can be obtained. Look at this one is a positive cosine theta, -2 cosine theta gives us the middle term. Therefore, This says cosine theta must be negative 1/2. This says it must be positive 1. Now, remember, if it's 1/2, I want to make sure we understand if it's positive 1/2, that gives us the reference arc of pi over 3 for cosine. Because it's negative, it means in the second quadrant, so pi minus pi over 3 makes it 2 pi over 3. And in the third quadrant, pi plus pi over 3, that gives us 4 pi over 3. And cosine is 1 when theta is 0. So from negative 1/2, we get those two answers. So this is the reference arc. Second quadrant, subtract this from pi. Third quadrant, add it to pi. So this is how we get these two. And those are the answers. Sine 3 theta is 1/2. We want to solve that. So how do we solve when we have sine or cosine of multiple angles? Here's the process. First, let's assume this is x. Sine x is 1/2. Therefore, we know the answer is between 0 and 2 pi, pi over 6 in the first quadrant, subtracted from pi in the second quadrant, 5 pi over 6. And we know x to be 3 theta. So first, finding those two should be easy. This pertains to x, but x represents 3 theta. So how do we handle that? The process is to say, okay, we're going to set 3 theta equals to pi over 6, and then to 5 pi over 6 and handle it by adding the 2k pi or 2n pi. So in the case of pi over 6, we say 3 theta is pi over 6 plus 2n pi. We're going to divide both sides by number 3. This becomes pi over 18. This becomes 2n pi over 3. We also have a 5 pi over 6. We are going to again add 2n pi. And when we divide by 3, this becomes 5 pi divided by 18 plus 2n pi divided by 3. And we choose n anywhere from 0 all the way to whatever this number is minus 1. So since this is number 3, we're going to go with 0, 1, 2, and we stop. And the reason we don't go with the next one, number 3, if you choose n to be 3, this n is 3, cancels this one, and it goes plus 2 pi, which is the one complete revolution after this number. So it goes to the same point that we started with. So if n is 0, this is pi over 18. If n is 1, 2 pi over 3 is the same as 12 pi over 18, because you're going to multiply this by 6, and pi 13 pi over 18, and the last one is 25 pi over 18. So replace the n with 0, 1, 2, and add them up. And remember, the common denominator obviously is 18. So simply put, you can multiply. One easy way is to rewrite this as plus. If you multiply by 6, you get 12n pi divided by 18. It makes it easier that way. So n is 0, this goes away. 1, 12 and 1 is 13, 2, 24, and 1 is 25. That's how you do it. And you do the same thing here. You can change this number to that, and now 5 pi over 18. If you plug in 0, you get the same thing. If you plug in a 1, 5 and 12 is 17 pi over 18. And if you plug in 2, 2 times 12 is 24, and 5, 29 pi over 18. So this is how we get all of them, and each and every one of them is within 0 to 2 pi in a complete revolution, and it doesn't go beyond that. Solve the right triangle. So let's plug in what we have. So we have A equals 8, B equals 2. This angle is 90 degrees. And we are looking to find this side. Pythagorean theorem says A squared plus B squared equals C squared. So this is 64. And 4 is 68. And the square root of 68 is the value of C. And by the way, square root of 68, this is a 4 times 17. That's how 4 becomes 2. This is the precise answer, or with a couple of decimals, we got this one. Now, how do we find the other angles? There are many different ways of handling it. One would be to say, okay, tangent for this angle is the opposite, B, over the adjacent A. And this is the best course of action because we already have both numbers, 2 over 8. And so it's 1/4, and beta becomes tan inverse of 1/4. And using a calculator, 0.25 radians or 14.03 degrees. And the reason we want to go with degrees because this was in degrees. And so if we add these two and subtract it from 180, or we don't even have to do that, subtract this one from 90, either way. And we got everything, so we can write A is 75.97, B is 90, C is 14.03, A is 8, B is 2, and C is 2 square root of 17. When you answer, you want to answer according to the way they ask you. They want the exact answer. This would be the answer. They want it with decimals, however many. A balloon is flying at a height of 600 feet directly above the Statue of Liberty. What is the angle of depression from the balloon to some airport that is 5 miles from the Statue of Liberty? Draw a diagram, and we should know 1 mile is 5,280 feet. That's a piece of information, so we understand what's going on because we always use the same units. This is 5 miles, this is 600 feet. So either we change this one to 5 times 5280, or we have to divide this one by 5280. So the very first thing I want to go over is the concept of angle of elevation and depression. To remind you, here's the horizontal, line, and here's the line of sight. Looking up makes up the angle of elevation, down makes up the angle of depression. Therefore, angle of elevation is the angle formed by the line of sight and the horizontal plane for an object above the horizontal, whereas angle of depression is the angle formed by the line of sight and the horizontal plane for an object below the horizontal. So that's the case for us, depression, angle of depression. So somewhere here is the balloon, and this is 600 feet. This is the airport, 5 miles. The drawing is extremely important. And here's the horizontal line, and here's the angle of depression. We know this angle to be identical to this angle because they are alternate interior angles. The two lines are parallel. And so one easy way, tan of theta, if you calculate this one, it's identical to this one. Tan of theta is the opposite, 600 feet over the adjacent, which is 5 miles. And right away, this one, we are going to change it to feet. It's easier to multiply this by 5280. We have to use the same units. And it becomes, and you write a lot of decimals, 0.022727, and theta is tan inverse of this number. If you use a calculator, it gives you 1.302 degrees. An aircraft is spotted by 2 observers who are 1,000 feet apart. As the airplane passes over the line joining them, each observer takes a siding of angle of elevation to the plane as indicated in the figure. How high is the plane? Well, let's put in the information here. This we call it y, this we call it h, and that's the height we are looking for. H is what we are looking for. First, let's understand what's going on. So there's a 40-degree angle here, 35-degree angle here, and the distance of 1,000 feet here. First and foremost, P or Q. This angle is 105 degrees. Why is that? Because this one is 90 minus 35 degrees. $55 degrees. And this one is a 90 minus 40, which makes it 50 degrees. And the yellow one is the sum of the two, which is 1. So we can use the sine law. Sine A over A equals sine B over B equals sine C over C. And here's the cosine law, A squared equals B squared plus C squared minus 2BC cosine A. And in this case, we have this side. We have the total angle here, 105 degrees. So for example, if I want to find the y, this side, since this is 35 degrees, I can handle it using the sine law. So sine of this side, 105 over 1,000, is sine of this side, that means 35 over the missing y. So y would be the product of these two, 1,000 times sine of 35 divided by sine of 105. And at this point, you use a calculator with a bunch of decimals. And so y or PR becomes 593.81 feet. Why did we find y? Because we are interested in finding h. And as you can see in this small triangle, the left side, sine of 40 is the opposite, which is h, over the hypotenuse, which is y. And we have the value of y. So h is the product of these two. Using a calculator, 381.69 feet. So the height is 381.69 feet. Two boats that are leaving the harbor in different directions make an angle of 135 degrees. One boat has traveled 300 feet, and the second has traveled 350 feet. How are these boats apart? You always want to draw a diagram. So let's see how it looks. So they are making 135 degrees between them. we call A, B, C. This angle is 135 degrees. One is going 300 feet, one is going 350 feet, right? How far are these boats? So we want to know the distance of a BC or A, lowercase a. So we can use the cosine law. A squared is B squared plus C squared minus 2BC cosine A. By the way, side, angle, side, the included angle is given. That's why you use this cosine law. And so A squared is, just look at this two sides. One of them is 300 squared plus one of them is 350 squared minus a 2 times the product of the two times cosine of whatever this angle is. It's 135 degrees. So 300 squared plus 350 squared minus 2 times 300 times 350 times cosine of 135, which simply put, is a calculator, of course. The cosine of 135 is the same as cosine of 45. In the second quadrant, cosine is negative. So this becomes minus cosine of 45 degrees, which is, this is minus cosine of 45 degrees. Cosine of 45 degrees is squared up to over 2. So it's negative of that, just in case. And plug into a calculator, find A squared, and we are interested in finding A. It's 600.83. As far as the decimals, should always follow what they ask you. Normally, they go with one more decimal. Since this is 300 feet, they probably stop here, but it's a good practice to put a lot of decimals if you have any doubts. Plot the points first, then find their coordinates, starting with the rectangular coordinates 6, 100. And we want to find the rectangular coordinate for 6, 150 degrees. This is in polar form r, theta. So, and I remind you that polar is in the form of r, theta. There's only one way to write x, y, but polar coordinates infinitely many different ways, because theta, we can change it to theta plus 2k pi. K is an integer, or 2n pi, depending upon the text. So add a complete revolution, it puts you back in the same location. If you want to make r negative, and most of the time we don't, then add odd multiples of pi. So theta plus 2k pi, another pi. This means 2k plus 1 times pi, which is the odd multiple of pi. So there are infinitely many ways of doing that. So with that being the case, you locate the angle first. 150 degrees puts you in the second quadrant, okay? And then you go 1, 2, 3, 4, 5, 6 tick marks. That's how you come up with the location when it comes to polar form. Now, we also have the following relationship. X is r cosine theta, y is r sine theta, and therefore x is r cosine theta, where r is 6 cosine of 5 pi over 6. And on purpose, I changed it to a radian form to remind you how we go from degrees to radian form. You don't have to do that. And it's the same as 30 degrees or pi over 6 as far as the reference arc is concerned. So cosine of pi over 6 is square root of 3 over 2. However, 5 pi over 6 puts us in the second quadrant. Cosine is negative. So minus square root of 3 over 2 is to cancel each other, minus 3 square root of 3. When it comes to sine, y equals r sine theta. Now sine of pi over 6 is the same as sine of pi over 6, because in the second quadrant, sine is positive. So 6 times 1/2 makes it 3, and we are done. So now this 6, 150 is the same as this, negative 3 square root of 3, 3, as far as the rectangular coordinate system is concerned. You recall that this is the origin, now the pole, This is the x-axis, so the positive side is called the polar axis. Now, given the pair 2, -2, we want to find its polar coordinates. We want to go back. So first and foremost, if we were to locate that, we go 2 to the right, 2 down, and that's the location. So 2 tick marks to the right, 2 tick marks down because this is negative. That is the location. And so in essence, you need to find the distance to the origin or the pole, that becomes r, and the angle theta. And so to do that, let's remind everybody that x squared plus y squared equals r squared. That's how you find r. And tan of theta is y over x, and you always adjust for the proper quadrant. Therefore, in this case, x is 2, y is -2, and x squared plus y squared gives us 8, because this is 4, this is 4. Therefore, r is the square root of that, which is 2 square root of 2. By now, everybody knows square root of 8 is 2 square root of 2. Tan theta is y over x, -2 over 2 or -1, and theta becomes negative pi over 4. As you know, tan, just like sine, goes from negative pi over 2 to pi over 2 as far as the inverse function is concerned. Therefore, r is 2 square root of 2, theta is minus pi over 2. So this pair has these coordinates. However, most of the time we may be interested in the positive value. All you have to do, add 2 pi, and it gives you 7 pi over 4. So if you want to go with the positive direction, it's a 7 pi over 4, 2 square root of 2, comma, 7 pi over 4. So you want to be very careful with that. Transform the polar equation r equals 2 cosine theta to an equation in rectangular coordinates and graph. All right, let's write a couple of things. X is r cosine theta. R squared is x squared plus y squared. And in this example, r is given as 2 cosine theta. So, what is the technique? The technique is to multiply both sides by r. So what happens? This becomes r squared. This becomes 2r cosine theta. Why did we do that? Because we know r squared is x squared plus y squared, and we know r cosine theta is x. Therefore, r squared is 2x, where r squared is x squared plus y squared. We move the 2x to the left. We put these two together. And we do completing the square by saying b is -2 divided by 2. Now square that, and you need to add 1 to both sides. This becomes x minus 1 quantity squared. That's the equation of a circle centered at 1, 0 with the radius 1. How do we know that? Because this is the equation of a circle in standard form centered at h comma k with the radius r. So 1 comma 0, radius squared of 1 or simply 1. So that's the center 1, 0. So 1 tick mark to the right, and this is the circle. Identify, graph the equation, and convert to a rectangular equation, and reminding everybody that x is r cosine theta, y is r sine theta, x squared and y squared, they add up to r squared, tan of theta is y over x, adjust for the quadrant always. So r equals 4. The technique is to square that because we know r squared is x squared plus y squared. So if you square that, you get r squared equals 16. And simply put, r equals 4 gives us x squared plus y squared equals 16. And this is a circle centered at 0, 0 with the radius 4. Why is that? Because x squared plus y squared equals r squared is a circle which has a center at 0, 0 with the radius r. And therefore, for this case, the center is the 0, 0 or the origin or the pole, and the square root of 16 is 4. And so that's the graph. When you have theta equals a constant, the technique is to take a tangent of both sides. And as you know, tan of 3 pi over 4, it's one of those common arcs. Pi over 4 gives you 1. 3 pi over 4 in the second quadrant is the same as pi over 4, but negative. Therefore, it's negative 1. And so this is negative 1. Tan of theta is what? Y over x. So y over x is negative 1, which means y is minus x. So when theta is 3 pi over 4, y is minus x. And that's a line through the origin going through 3 pi over 4, 7 pi over 4 in essence. So the synopsis of that is when r is a, we have a circle centered at the pole or the origin with the radius a. When we have r sine theta equals a, it's a horizontal line. R cosine theta equals a is a vertical line. If theta is a constant, then we have a line y, which is tan of theta or tan of k, whatever you want to call that, times x. R sine theta equals b, it's a horizontal line y equals b. R cosine theta equals a is a vertical line x equals a. When r is 2a cosine theta plus minus 2a, or r is plus minus 2a sine theta, all of them result in a circle with a radius a, and the center in the case of a cosine is along the x-axis. In the case of a sine is along the y-axis. If we were to graph this, graph 1 minus cosine theta, it's an easy way is to plot points, and easy points, for example, from 0 to pi. And I'm reminding you that r times a, r equals a times 1 plus minus cosine theta, or plus minus 1 sine theta. They are all cardioids. So we have an idea as far as the shape. So how do we graph this? If we pick up a few points, for example, 0, pi over 6, so on and so forth. I'm going to graph just a few points here. If I plug in 0, as you know, cosine of 0 is positive. 1 minus 1 makes it 0. So this gives you 0. Pi over 6, square root of 3 over 2. 1 minus square root of 3 over 2. Let's go with the easy one. Pi over 3 is 1/2. So 1 minus 1/2 is 1/2. Let's go with 2 pi over 3. Now 2 pi over 3 is the same as pi over 3 in the second quadrant. Cosine is negative, so 1 minus negative 1/2, which means 1 plus 1/2, which means 3/2. Pi, cosine is negative 1, so 1 minus negative 1 makes it positive 2. So this is what we have, and those are the pairs. So I did that last time. Let's graph the easy ones, 0, 0, of course. So I'm looking at the easy ones. 1/2, because 1 minus square root of 3 over 2, you have to really have a decimal approximation. So pi over 3, and then 1/2, let's say somewhere here. This is not to scale, of course. Oh, 1 and pi over 2, by the way. If you plug in pi over 2, cosine is 0. So 1 and pi over 2. I should really go here and then maybe here. And then 3 halves, 2 pi over 3. So 2 pi over 3 means 120 degrees. So somewhere here. So 2 and pi, so somewhere here. So look, this is by no means too scale. This looks something like this, class. And of course, this is a much better graph, no question about that. What is we are going to add? R is 1 minus cosine of minus theta. If I change the theta to negative theta, nothing changes, which means it is symmetric with respect to WRT also means with respect to the polar axis, x-axis, because R theta can be replaced by R comma minus theta, resulting in an equivalent equation. The graph is symmetric with respect to the polar axis. Therefore, I mean, you can see, actually graph it using this fact without doing anything else. But if we continue with these thoughts and get more pairs, for example, 4 pi over 3, 3 pi over 2, 5 pi over 3, 2 pi, all of them are easy numbers. As an example, 4 pi over 3, that's the same as 2 pi over 3 gives you negative 1/2 minus 1/2 is a positive 3/2. So 3 pi over 2, it's 0, so that gives you 1. And so you can graph those, and they look like this, which is a lot better than what I have, obviously. But gives you an idea. So a rough sketch by hand even can be done, even though it may not be precise. Plot the complex number 1 plus I in the complex plane and write it in polar form. And we want to write the theta in degrees. So first and foremost, let's remember the idea of the complex numbers are the same thing that we have studied. A plus bi, everybody remembers that, where I by definition is square root of negative 1. So z is x plus yi, or rc is theta, which means r times cosine theta plus I sine theta. This is a shorthand notation. And r squared is x squared plus y squared. So the magnitude or the modulus or r is the square root of that. And to find the angle tan theta is y over x. So this is the polar form of the complex number. And this is the complex plane. This is the complex plane. So here's your x-axis, which is going to be the real axis. Here's your y-axis, which is going to be the imaginary axis. So here's r, the magnitude, the modulus. Here's theta. And by the way, we also have, sometimes they call it z star, z bar, z prime, and that's the complex conjugate. As you recall, the complex conjugate for a plus bi was a minus bi, so x plus iy becomes x minus iy. So again, I want to write that because I want you to remember, really, you're dealing with the same concept as a plus bi, where I is square root of negative 1. And if you multiply a plus bi by a minus bi, you get a squared plus b squared. That's why this is absolute, sometimes the product of z and z bar in an absolute, in a square root. So in order to come up with the answer, let's find r, which is finding the square root of x squared plus y squared. So first 1 and 1i, so one along the real axis, one along the imaginary axis instead of calling it the y-axis. And so 1 squared is 1, 1 squared is 1. So this modulus, this magnitude, this r is square root of 2, and tan of theta is y over x, which is 1. And since it's in the first quadrant, theta becomes pi over 4 or 45 degrees. And so z, which is 1 plus I in the form of r cis theta, let's replace the r with square root of 2 and theta with 45 degrees. Why degrees? Because they wanted it in degrees. Write the complex number 4 cis 7 pi over 4 in rectangular form and plot the complex number. So we can basically multiply this by replacing 7 pi over 4. What is cosine of 7 pi over 4? Remember, pi over 4 in. So for that, the reference arc is pi over 4. Remember, 8 pi over 4 means 2 pi. So 7 pi over 4 puts you in the fourth quadrant. In the fourth quadrant, cosine is positive, so it's the same as pi over 4. Cosine of pi over 4 is square root of 2 over 2. Sine is negative, so it's negative square root of 2 over 2. Now, if you multiply by 4, the denominators 2 and 2, they drop out. So we get 2 square root of 2 minus 2 square root of 2i. So we wrote it, and let's do the plot. This angle because 2 square root of 2 and minus 2 square root of 2 means going in the positive direction of the real 2 square root of 2, and coming down 2 square root of 2 puts us in this quadrant, and that is theta equals 7 pi over 4, right? 7 pi over 4, looking like that, and that's the location. And again, it may not be exact, but it's close enough, because square root of 2 is about 1.41, and 2 times that is about 2.8, so it's a little bit less than 3. We want to find ZW, Z over W, and leave the answer in polar form, where Z is given as 2 cis pi over 8 and W is given as 2 cis pi over 10. So let's go over a couple of things. Number one, we said here's Z, here's R cis theta, and all of the above. We are adding the following. How do we multiply two complex numbers in polar form? Z1, Z2 is R1, R2 cis theta 1 plus theta 2. Simply put, multiply their modulus and then add up their arguments. So let's first do the multiplication. So we're going to multiply 2 by 2, becomes 4, and we're going to add pi over 8 to pi over 10. So this gives us a 4. And this one, 40 is the common denominator, pi over 8, 5 pi over 80, pi over 10, 4 pi over 40, so 9 pi over 40. This is done according to what they asked. Now we want to go with Z over W. And how do you come up with the division? You divide R1 and R2, and then you write the difference of arguments. So 2 over 2 cancel each other. And then pi over 8 minus pi over 10. So 5 pi minus 4 pi. That means pi over 40. And we are done. We want to write in standard form the square root of cis 5 power 18 to the power of 6. So let's add the Morse theorem when n is larger than or equal to 1. How do you raise a complex number in polar form to a power? Z to the power of n is R to the power of n. Raise the number to the power of n and then multiply the argument by n. So I'm going to raise, if I want z to the power of 6, if I call this z, then I raise this to the power of 6, and then I multiply this by number 6. This is the same as 3 to the power of 3 because it's square root of 3, or you can say this is 3 to the power of 1/2 to the power of 6 becomes 3 cubed. And this one, 6 goes away, and 18 changes to 3. Now, 3 cubed is 27. 3 cubed is 27. 5 power 3, the reference arc is power 3. 5 power 3 in the fourth quadrant, so let's just first write. The reference arc is power 3. So we can replace it with 5 power 3. For cosine, it's the same because cosine is positive, but sine is negative. So this becomes minus, or you can say minus sine power 3. Either way, this changes to negative when you go to power 3. Again, cosine is positive in the fourth quadrant, sine is negative. As you know, power 3 cosine is 1/2. Sine is square root of 3/2. And so this is 27 over 2 minus 27 square root of 3 over 2i. This is the standard form or rectangular form. Standard form or rectangular form, depending upon the text and how you deal with that. So you want to be comfortable with the terminology. Z is 8. Find all complex cube roots. So we've discussed all of those. Now, how do we find the cube roots? Here's how we find it. If W is R cosine theta 0 plus I sine theta 0, and n is larger than or equal to 2, there are n distinct complex nth roots of W as follows. Z sub k is the nth root of R, so we take the nth root of R after we put it in the proper format. Theta 0 over n, and then we add 2k power n, or 360, because both of them means a complete revolution. If it's in degrees, 360k. If it's in radian, 2k pi. And then we let k be 0, 1, 2, all the way to n minus 1. So in this case, we want the cube root. That means k is 0, 1, 2. Cube root means there are 3 of them, so 0, 1, 2. All right, so first and foremost, we recognize that this is 8 cis 0. Why is that? Any real number, z equals 8, 7, 5, 1/2, whatever, that it doesn't have imaginary part. This part must go to 0, and the angle is 0. It's along the x-axis. Okay. Now, if it happened to be negative, then you use pi, because cosine of pi is -1, sine of pi is still 0. So any positive number, real number, cis 0. So whatever this number is, 8 cis 0, 10 cis 0, whatever that number is. But if it's negative, instead of 0, you use pi in general. Therefore, let's stick with now this. We are going to go with the cube root of 8. Cis 0 over 3, this is the original angle. Theta 0 over n, that means 0 over 3, plus 2k pi over 3, or 360k over 3, either way. And since this goes away, this is 0, we have just this part. And as you know, cube root of 8 is what? 2. So 2 cis 2k power 3 and we replace the k with 0, 1, 2. Again, why is that? Because when we say cube roots, n becomes 3. That means the third root. Cube root, the third root. So if you plug in 0, clearly you get 2c0. If you plug in 1, you get 2c 2 pi over 3. If you plug in 2, 2c 4 pi over 3. Now, this is simple. 2c 0, remember this one is just simply 2 because it's cosine of 0, I sine of 0. What is this one? This is a 2 cosine of 2 pi over 3 plus I sine of 2 pi over 3. And 2 pi over 3 is the same as pi over 3, but in the second quadrant, it's negative. So this becomes cosine of pi over 3, but negative, plus I sine of pi over 3, but positive, because the second quadrant sign is positive. And so we get minus 1/2, my apologies. So we get negative 1 plus I squared of 3. Let me look at this one. This is 2 cosine of 4 pi 3 plus I sine of 4 pi over 3. Now 4 pi over 3, that means the third quadrant, both of them are negative, both of them like pi over 3, and therefore this is minus 1, this is minus 1/2, I mean, minus square root of 3 over 2. So both of them are negative. And when you multiply by 2, the denominator goes away. Therefore, for this one, the answer is 2. For this one is negative 1 plus I square root of 3. And for the last one is minus 1 minus I square root of 3. Vector V has initial point P and terminal point Q. Write V in the form of AI plus BJ. Find its position vector. Also find its magnitude, where P is given as 3, 2, Q is 5, 6. So let's remind everybody of what's going on. When you have a vector that has the same magnitude, the same direction, they are considered identical. And when the initial point is at the origin, it's called the position vector. So position vector, if a V has components A and B, is an algebraic vector whose initial point is at the origin, then V is called a position vector, algebraic vector AI plus BI, and so on and so forth. And a vector with initial and terminal points is equal to the position vector x sub 2 minus x sub 1, y sub 2 minus y sub 1. So this is the case here, and we are going to write 5 minus 3, 6 minus 2, and that is 2, 4. It's the same as writing 5 minus 3 times I plus 6 minus 2 times j, or just look at this one and write 2I plus 4j. You don't have to go through that. I just wanted you to see how it works, but this really means these two are identical, of course, different form of writing it. And what is the magnitude? Magnitude by definition is, or the modulus is the square root of a squared plus b squared. The magnitude is always positive, or worst case scenario is 0. If it's 0, the vector is a 0 vector, and the magnitude of two vectors that are opposite are the same. If you multiply it by a, and a is a scalar, you can put it in an absolute value. So what is the magnitude in this case? For V, This one is 2 squared plus 4 squared under the radical. And this is 4, this is 16, 20, as you know, square root of 20 is 2 square root of 5, simply because this is 4 times 5, and 4 comes out as a 2. We have those two vectors, and we want to find the following. So the magnitude, we've already done that. Minus 2 quantity squared plus 3 quantity squared. And this is 4, this is 9, and that's the square root of 30. We want to add them up. So simply put, let's add them up. When we do that, minus 2i and 5i, positive 3i, 3j and minus 4j minus j, and we are done. So just the way you do operations on basic numbers. 2v minus 3 times w, so 2 times v minus 3 times w. So distribute minus 4i plus 6j minus 15i plus 12j, and minus 4i with minus 15i. That gives us negative 19i, these two add up to 18j. We want to find the magnitude, direction, angle, and a unit vector in the same direction for the following vectors. So again, we have those information, and to find the magnitude is simple. 3 squared is 9, 3 squared is 9, is 18. Square root of 18, you should know it's 9 times 2 is 3 square root of 2. The next thing is to remind everybody about this, that any vector is its magnitude times its direction, cosine alpha I plus sine alpha j, and v has the value of 3i plus 3j, so we can calculate the tangent accordingly, which is y over x, or 3 over 3, or 1, and as you know, the angle is pi over 4, or 45 degrees. Therefore, we can write this as the magnitude times cosine of 45 degrees I plus sine of 45 degrees j. Remember, I is the unit vector along the real axis, j is the unit vector along the y-axis. All right, so we want the unit vector, and to find the unit vector, all you have to do, divide by the magnitude. And so AB, this is A times 1, 0 plus B times 0, 1, AI plus BJ. This is another way of looking at the concept of a unit vector. So all you have to do, divide this vector by its magnitude. So the 3's go away. So we have 1 over square root of 2 in both cases. I hope you realize that you have 1 over square root of 2. And 1 over square root of 2 times square root of 2 over square root of 2 gives you square root of 2 over 2. I hope you know that. So that's the answer. And you can always check by raising this to the power of 2, raising this to the power of 2, add them up becomes 1, and the square root of that is also 1. So you can always check. A rocket takes off at a bearing of north 30 degrees east. After flying for 900 meters, the pilot turns 90 degrees and heads northwest. After flying for 1,000 meters, what is the new bearing of the plane? Draw a diagram. So let's discuss a couple of things. Number one, reminding you of the bearings, and if you want to go with north and south. So this is north. When we go 30 degrees east, this is north 30 degrees east. This one is north 70 degrees west. Looking down, we start with south. This way would be south, for example, 50 degrees west. This would be what? South 20 degrees what? East, just as an example. So now, north 30 degrees east is this way, north 30 degrees east. And it goes for 900 meters. Then there's 90 degrees. So we're going to make it 90 degrees this way or that way. It says northwest, so that way. And we go for 1,000 meters. That creates a new vector. That's the diagram. If this angle is, we call it alpha, then what is the direction? North, alpha, west. North, alpha, west. So we need to find this alpha. So let's go through that. Everybody understands what we need to do. So having said that, this angle is theta, and this is a 90-degree angle. So tan of theta is the opposite, which is 1,000 over the adjacent, which is 900. 10 over 9. So take the tan inverse of 10 over 9 becomes 48.01 using a calculator. So theta becomes 48.01 degrees. If this angle is 48.01 and this much was 30 degrees, then you subtract the 30 degrees and that gives you alpha. So again, this whole thing, we proved it to be 48.01. We're going north 30 degrees east. This direction was 30 degrees. So we subtracted, and now the answer is north 18.01 degrees west. That is the direction. A plane is flying at a speed of 200 miles per hour on a bearing of north 55 degrees east. The wind is blowing from west to east at 35 miles per hour. Approximate the ground speed of the plane to the nearest mile per hour and the true course of the plane to the nearest tenth of a degree. And we know of this. So let's do the drawing. So we are going north 55 degrees east. The wind from west to east. And it creates a new direction with a new magnitude. Therefore, what is it that we are looking for? We need to find this angle. This will help us with this angle, which is 90 minus that. So they are asking for the true course. So we want the magnitude. That's the ground speed, magnitude. And then we are going north, east, with this angle, which is 90 minus theta. So I want everybody to see what is it that we are looking for. Again, if you look at the red line, the magnitude we need to find. And this angle will give us north 90 minus theta east, because this is theta. And why are we using that? Because there's a way to find theta. Let's go through the process. So velocity relative to air is given to be 200 miles per hour, and the direction was north 55 degrees east, which means for this one, the angle is 35 degrees. That's what we need with respect to the positive side of x. The wind is doing 35 miles per hour parallel to the x-axis. The angle is 0 degrees. So let's write this formula for both of them. For VA, 200 cosine of 35 degrees I plus sine 35 degrees J. And of course, cosine of 35 and sine of 35, use a calculator. And you write it with the I and J component. The same thing happens with the wind. Cosine of 0, we know it to be 1. Sine of 0, we know it to be 0. So simply put 35I. Again, let's just quickly write that. So this is 1. And this is 0. And as you can see, the two add up. So what do? We add up their components. And these are the two that they get added up, and this remains unchanged. 35 and 163.83 gives us 198.83i plus 114.72j. To find the magnitude, remember the magnitude is square root of a squared plus b squared. So we raise this to the second power, we raise this to the second power, we add them up, and the calculator gives us 230 miles per hour. Now, for this, we can find theta or alpha, if you will, and it's the j component over the I component. Using calculator, we get 30 degrees. If this is 30 degrees, the answer is 230 miles per hour, north 90 minus 30, that means 60 degrees east. And that's the final answer.